This time I'm going to use cobalt 60 as my gamma source. So I'm going to mount the gamma source above the Geiger-Müller tube.
That's quite a lot lower count rate.
There's two answers to that. The first is that the Geiger-Müller tube is not as good at detecting gamma rays. And secondly, the number of gamma rays produced by this source is quite low. If I put the aluminium in the way, the aluminium is not absorbing many of the gamma rays as they pass through. However, if I introduce some lead, it's only with a couple of centimetres of lead in the way that the count rate is significantly reduced, because gamma rays can pass through lead, but several centimetres starts to significantly reduce the number getting through.
Reduced but not stopped.
Yeah, to completely stop the count rate, we have to have several tens of centimetres of lead.
Why is it that lead stops it as opposed to another metal like aluminium?
OK, the aluminium itself is quite a light metal. Its density isn't very high, as opposed to lead, which is very dense, which will absorb the gamma rays as they pass through.
Handling the absorbers with the bare hands is quite safe. The problem arises if you're tempted to put the absorber close to the source with your fingers. So we always recommend that an absorber should be handled with forceps if you've got a radioactive source nearby.
The other thing that we can start to try and show with this setup is how the range of the gamma rays in air is linked to the inverse square law. So hopefully if I double the distance they are away, the count rate will go down by a factor of 4. So at the moment my source is roughly 4 centimetres away, and if I double that to 8 centimetres, the source will now be counting at about a quarter the count rate.